We have NASA, the US space program, there's a European space program, Dubai has a space program, Russia has a space program. Now we've discovered that many of these stars also have planets, and your students will ask you, how do we know they have planets? How do we see them? There's a method by which scientists use. There are these very, very large telescopes. Telescopes that are big as a house, bigger than a house, very massive, very big. And when they peer into space and look at the stars, they look for deflection in the light of the stars. In the sense that because even our own sun, if you are in space or you have a telescope looking at the sun, it's dangerous. Don't look at the sun with the telescope only because it can blind you. There are special ones that we use to look at the sun. Whenever any of the planets go across the sun, it takes away from the light of the sun. You can do an experiment in your classroom. A big ball of light is the sun. Then smaller balls, very tiny balls, are planets. Whenever they pass across the sun, a little piece of the sun's light is dimmed. A little spot is now darker. That's why scientists know that, oh, this star must have planets. So we've now discovered many planets using that method. So basically we have many solar systems. We've already told you the closest star to us, Proxima Centauri, and its triple star system. There are other stars that you should know we've discovered. In the past, we talk about constellations. Let your students know about constellations. The constellations you can see in Nigeria. You will not see them in England because you know the Earth is round, and it's a southern hemisphere. But the constellations are the same in the southern hemisphere and northern hemisphere. Let them know the important names of the stars, and these stars form shapes that man has known for thousands of years. Find out these shapes. Let it be an exercise for your students when they go home. When they go home, tell them that. Tell them the most famous constellation. Constellations are a group of stars that form a shape that we can easily see. You tell them the important constellations, and then draw them whenever the sky is not cloudy and show you at your next meeting. So the speed of light gives you an idea of the distance and the massiveness of space. It takes light 4 years, 4.3 years, to get to the nearest star. So the nearest star that we are looking at right now, Alpha Centauri, the light you're looking at it the way it was 4.3 years ago. If that star has blown up, we will not know for 4.3 years. But if we are traveling with a spaceship to that star at the speed we are going, it will take us 50,000 years because we don't yet have any spaceship that can go at the speed of light. We don't have that capacity yet. We are building, we hope to have a spaceship in not too long a time that will go 10% of the speed of light. So it'll take us 40 years to get. That'll be an amazing day. It hasn't happened yet. Or maybe one day it'll happen. So when you talk of the speed of light, it gives you an idea of the massiveness of space. One thing we do in space, instead of talking about miles and miles and miles, there is what we call the astronomical unit. It enables us, it's like when you have, Zimbabwe, their money became so bad, just also like Germany before World War II and Zimbabwe some years ago, the country became so bad that to buy a loaf of bread, I think you needed like 100 million Zimbabwe dollars. Where will you pack 100 million to go and buy a loaf of bread? What if you want to buy a car? What if you want to buy a house? What if you want to go and buy 100 loaves of bread that you have like 100 billion? Where will you pack all the money? So it becomes likewise in space. It's so big that if you're talking of the distance from here to the nearest star, I think you are talking of 49 trillion kilometers. What about the star that is even further? Would that one now be 100 zillion billion? So instead we have what's called astronomical unit, or AAU, and this is defined as a distance from the Earth to the Sun. And let me ask you a question. What is the distance from the Earth to the Sun? 92 million miles or 149 million kilometers? So that gives you 1 AAU is equals to 149 million kilometers. So that gives you an easier way to measure and explain distance when you're talking of large portions of space. So, for example, while the nearest star, Proxima Centauri, and as we have said before, it's almost 49 trillion kilometers, when you talk about astronomical unit, that will be 286,000 astronomical units. It's a term that's used, you don't have to bother yourself too much about it, but at least know it, understand it, so when students ask, you can be able to explain to them.